Hello everyone, my name is Alyounes, and I am from the Scopus Institute of Science and Technology Scopus. I'm glad to introduce our paper TeslaCharge, smart robotic charger driven by impedance control and the human haptic patterns. 10 million electric vehicles were sold in 2022, with an expectation of a 35% increase in 2023. However, these vehicles are not suitable for everyone. A survey of people with impairments was conducted by the British Research Institute for Disabled Consumers, showing that only 25% had the desire to use electric vehicles due to the physical effort required to charge them. Well, this number increased to 61% when these charging stations were promised to be enhanced. The charging process can be subdivided into three main phases. Phase 1, locating the socket. Phase 2, plug in the charger. And Phase 3, plug out the charger. Typically, the effort in the research is focused on the first phase, which resulted in the accuracy of 5 millimeters at 10 degrees. However, this accuracy is not enough to complete the task. In this work, we designed a novel methodology for robotic plug-in and plug-out phases based on the human haptics to overcome socket orientation errors. To measure the human data, we designed a setup to help participants perform the task. The system consists of a 6 degree of freedom force torque sensor to measure the applied forces, and 2 Tsetserukou markers to detect the movement of the charger by a camera. A holder was also designed and attached to the system to help participants in holding the setup. 23 participants volunteered in the experiment, performing the plug-in and plug-out phases. Their data was processed to design a controller in order to apply it on the robotic charger. 3 controllers were designed based on impedance control to mimic human patterns. The recorded data from the humans were used to calibrate the parameters of the impedance controllers, the inertia, damping, and stiffness. The system response for their controllers was assumed to be a system of the second order with no overshoot, and with the settle time of 0.2 seconds, which is the same speed as in the human performance. A robotic validation was performed where the designed controllers were applied to a universal robot UR10. The force torque sensor measures the interactive force between the charger and the socket, and the PC accordingly calculates the speed of the robot depending on the desired controller. Using the proposed controllers and the human kinesthetic data, it was possible to successfully automate the operation of charging an electric car. We can see in the video above how the robot is adjusting the movement during the plug-in phase, up, down, and left-right movements. In the other video, we can see how the robot is performing in the plug-out phase. Well, thank you for your attention. We'll be glad to discuss our results in the poster session.